So there are some notes about this posted, and much of the posted notes are things we already know, but we're finally ready to actually go through the entire family of different join operations that are available. And we'll notice that there really is only one member of the family that we haven't already met. But it's time to do it. And we'll actually notice, and I foreshadowed this earlier, that some of our earlier applied SQL that had to do some ugly union operations can be done much easier if we leverage what we now know about null values for aggregation and what we're about to learn about something called an outer join. So what is a join operation? A join operation is some way of combining data from two tables based on taking a row from one table and matching it up with 0 or more rows from the other one. And so we'll walk through the members of the family. We'll just revisit them in the same order that we introduced them originally. So here we'll select everything from our products table. That shouldn't be too surprising to us by now. Let's actually make this, we're going to need more space for this eventually, so we'll make that a bit bigger. We know already that we have this operation. We can actually use the comma for it, but I like to write cross join order contents. And we saw as our motivation for natural join that this is of very little help to us. Cross join does come up in some sort of utilitarian aspects, as we've seen in our applied SQL, but not usually for exploiting existing relationships in data. Usually it's for things like artificially constructing a set of pairs or something like that. So we've seen cross join, and cross join is a join. It's a Cartesian product, which is a way of creating a big table by combining rows of other tables. But it doesn't actually map rows based on some sort of relationship. It just pairs up everything with everything else. The next one I want to talk about, so we of course have talked about natural join a lot. I want to talk instead about something called, I think I will format it like this, inner join. So we'll see that inner join is actually just meant for contrast with outer join. I'm going to do products inner join order contents on. So the inner join operator is a weird one because in modern programming languages we wouldn't have an operator that has two pieces like this. The inner join operator consists of two parts. It's two operands separated by the word inner join, but they must be followed by a description of the join criteria. The join criteria is not the same as the where clause. This is all being done inside the join operation. Maybe for the sake of it being more clear, I'll put the whole thing in brackets. So on, I want products dot product ID is equal to order contents dot product ID. And we can see that this might resemble the result that we created when I used a cross join and the where clause to restrict the, to sort of perform a manual natural join. And the idea of the inner join operator is first, I can nest it as many levels deep as I want. So I could do several layers of inner joins, each with its own on clause. And the on clause contains any Boolean expression I want. So here I'm using only one piece, one sub-expression, but I could use a lot of other ones. I could chain them together with logical and or logical or. And notably, I'm allowed to use any operator I want, which I'll get to in a second. The idea behind inner join is that we take every row from the table on the left, products, and we attempt to find some row or rows in the table on the right such that this condition is met. If we find them, we pair them up and we generate this result. And like with the cross join, we'll see a copy of the columns in common from both tables. Because the join condition could be anything. They may not necessarily be equal. They could be the column that both tables contain, but they may not have the same value. And so inner join generates all possible pairings that obey the conditions. And it is essentially the same as a cross join plus a where clause, but it's done inside of one operator, and it might be the case that the database can interpret it in a way that's easier to optimize. So we have that, and I want to quickly talk about a different way of writing it in Postgres. We can, instead of saying on and giving an expression, I can give a list of join columns, which are assumed to be common columns. And when we do that, we get something more close to a natural joins output. So that because the using clause implies that the columns have an equal value, there's no need to keep both copies of the column. The reason I might want to do this is because I could be joining tables whose natural join would join them on multiple columns, where I only want to join them on one of the various columns they have in common. So the using clause, I could give multiple column names here, but the using clause allows me to choose whichever ones I want. What I want to talk about, though, is another use of inner join, which is, what if I join a table back to itself? So I'm going to make two copies of my products table, products as P1, products as P2. On, and here I'm going to join the price per kilogram column so that I keep all the rows where in P1 the price per kilogram is less than the price per kilogram in P2. And you might remember a query we did in an applied SQL lecture that dealt with this same issue, and I think it did it with a cross join and a where clause. So here I've got product ID 1, whose price is 3.5, maps to 2, whose price is 4, and maps to 3, whose price is 5, and maps to 4, whose price is 10. But we'll notice that product ID 2 doesn't map to product ID 1 because it's not the case that the price over here is less than the price 3.5 for product ID 1. So I can specify any condition I want. And you might remember that we've done queries where we ask things like, list the number of products that are more expensive or less expensive than the product. And so one solution is to use an inner join. And you will also notice that, like a problem that we had when designing that query initially, was that the most expensive product was left out. And that's also the case here. The most expensive product is raspberry, and you will notice there is no row for raspberry on the left because raspberry is not less expensive than anything. And to participate in the join, the row from P1 has to be less expensive than something in P2. I think we already resolved that one remedy to that, if you need that product in there, just to get it in there at all, is you could use less than or equal to, which adds a row mapping the product back to itself, basically. So we have inner join, and I actually now finally want to talk about what exactly is a natural join. So a natural join is in fact a form of inner join by default, but the way that the word natural factors in SQL is, I guess I will rewrite the query I had before. So the join we've been doing all semester of joining products to order contents, that is a natural, we just keep writing natural join. So it turns out that actually the word natural is a modifier you apply to any join that removes the on part of the join. So if with a normal inner join, we would have down here this bit on something. And the only thing that the word natural does to our join operation is it automatically sets the on criteria to be all of the columns that are in common between the two tables. So there is no such thing really as a natural join in SQL. There is an inner join, an outer join, and a cross join. And the inner join and the outer join have an on or using criteria. And if you use the word natural, those get filled in with default values, which is the natural inner join is all of the columns in common. It's also worth noting that it is absolutely valid to just write join. And I could here write join on products.product ID equals order contents dot product ID. And so if you just write join by itself, okay, whoops, autocomplete. If you just write join by itself, SQL interprets that to mean inner join. And just like how I don't like the use of a comma for a cross join, I really prefer writing inner join. I get that you don't have to do it because by default the word join means inner join, but writing inner join makes it much more clear to anybody reading your query what you intended to do. If somebody sees this, they might say, what kind of join do you want? Do you even know what a join is? Here it's obvious you want an inner join. The reason why this might have already been clear that there is a way of just saying join by itself is that based on what I just said, if the word natural is just a modifier, then if I type natural join, like I've been doing all semester, what kind of a join is it modifying? And it turns out that natural join is the same as writing natural inner join. So an inner join is something we've actually already been familiarized with, and the idea is that we take every row from the table on the left and we attempt to pair it up with rows on the table on the right. If we can't pair something up, so if there's a row in the table on the left that can't be paired up, then we just don't. We don't admit it at all. And if there's a row in the table on the right that can't be paired up, we just don't admit it at all. But there's a question. What if we still want to know about that? What if we have the products table and the order contents table, and we know that there are certain products, in particular apples and pineapples in this example, that never appear in an order? What if I want to join them and I still want to retain that information? We've seen already there are ways of getting it. I could always do two separate queries, one to get the products that are in an order and one to get the products that aren't. What if I want the join to provide me both things? And so the other type of join, the other major type of join besides an inner join, is an outer join. An inner join only keeps those rows that do get paired up. An outer join consists of all of the rows an inner join would produce, plus extra rows as placeholders for the things it couldn't pair up. And it turns out that you can't just write outer join. You're expected in SQL to explain what kind of outer join you want. So I'm going to start with left outer join, and I'm going to do on products dot product ID equals order contents dot product ID. Take a look at the result. So just like the inner join, we pair up order number 1000 contains product ID 3, which is a lime, and there's its price. Order number 1002 contains product 4, which is a raspberry. But down here at the bottom, once the join is complete, the outer join operator figures out which things, this is a left outer join, which things in the table on the left never got paired up. And for each of them, it emits a row where only the columns for the left-hand table are filled in. And the other ones, because of course there was no way of pairing up the row for pineapple, the other columns are set to null. So a left outer join, you're guaranteed to see every row from the left-hand table at least once. It could appear more than once. So we see pair appears twice here. But every row from the table on the left is guaranteed to appear at least once in a left outer join. A right outer join is the same thing, but for the other side. So in this case, the right outer join generates at least one row for everything in the table on the right. It guarantees nothing about the table on the left. And you can see that there is no longer a row for pineapple or apple. They don't appear in the order contents table at all, but the right outer join only adds the placeholder rows for things that appear in the right-hand table, but not the left-hand table. And it turns out in this data set, actually, that order contents, every order does contain at least one product, and so that there is no issue of something appearing in the right-hand table but not the left one. But for the sake of argument, if I swap these two tables, we can see that the right outer join, again, it nulls out all of the columns for the left-hand table and generates a placeholder copy of every row that appears only in the right-hand table. And finally, there is something called a full outer join, which is to do both. So in a left outer join, there could be some rows that have all null values in the columns from the right-hand table. In a right outer join, there could be some rows with all null values in the columns from the left-hand table. And in a full outer join, there could be rows with null values in either the columns from the left or the columns from the right. Now again, it's not as obvious in this example because only one of the tables is not represented in the other table. So I only see the rows that for the products that never occurred in an order. So I have left outer join, full outer join, and right outer join. The notes that I posted on this talk about the fact that it turns out that if all you really need is left outer join. You can produce right and full outer joins using the left outer join. And although Postgres, as you've just seen, supports all of them, a lot of other database systems, because it's computationally intensive, do not. SQLite only supports left outer join as of recent versions. And so if you want a full outer join, you have to sort of synthesize it using two left outer joins. Finally, because we've seen that the natural keyword is just a modifier, that means I should be able to perform a natural outer join. And it turns out that the word natural just says don't have an on clause. Instead, assume that the criteria is the default criteria, which is all of the columns in common, and then perform the outer join based on that. So I can use a natural right outer join or a natural left outer join to produce my result. And in my mind, if we have a schema that we trust, if we know that the columns in common make sense, I really prefer using a natural outer join and a natural inner join to using some kind of qualified inner join on some columns or inner join using some columns, because I feel like that's a bit less natural. It's also harder to write, it's harder to debug, and if something changes, you have to go change your query. So I want to do one last example to solve a problem we've already solved. I'm going to select products as P1, and then I'm going to do a natural left outer join with products as P2. So we'll take a look at that. Okay, so a natural join, of course, joins the table back to itself. Now, if I then add my query, if I then go back in and add my on clause as I had earlier. So I'll do on P1.price per kilogram is less than P2.price per kilogram. Let's think about this. We already saw that with the inner join version of this, there were lots of products like Apple. So Apple gets paired up in this case, the price of apple is less than pear, lime, raspberry, or peach. So apple gets paired up with 4 things. There are 4 rows in my result where the P1 row is apple. For lime, there will be 2 rows, raspberry and peach. But for raspberry, there is 0 with the inner join. There are 0 things in products whose price is greater than raspberry. But I'm not doing an inner join. I'm doing an outer join. P1 left outer join products. That means anything in P1 that doesn't end up in the result gets a row to itself with null values on the right-hand side. So if I try this, I will notice in the result there is a row for raspberry. And the product ID of the more expensive product is null, because obviously there wasn't a more expensive product, but it's in my result. And that means if I want to do some sort of aggregation based on every product, I don't have to look any further. I actually now have every product appearing on the left-hand side. So what I want to recreate is that query that we did before, which is count the number of products that are more expensive. So I'm going to group by, so in this case, for example, there are 5 products more expensive than pineapple, 1 product more expensive than peach, 2 products more expensive than lime. So I'm going to start by trying this, p1.product ID, and I'm going to select p1.name, the product on the left, and I'm also, I'll just as name, I'm going to get rid of the p1, and I'm going to select count star as, and this is going to turn out to be incorrect. We'll debug it. More expensive products. So it says apple has 4 products that are more expensive, pear has 3, lime has 2, peach has 1, but raspberry shouldn't have 1. That doesn't make any sense. And the issue here is that there is a row in my table for raspberry. That's how I'm seeing it there to begin with. When I toss that into the bucket and then count all the rows in the bucket, I am seeing that row of all null values, and it gets counted as 1. So at the end of the video about null values, I pointed out that we also could do something like try and count the number of other product IDs that it gets mapped to. So P2, the rows that come in from P2 are the things that are more expensive than the current product. So for example, for lime, there would be a P2.product ID would equal the one for raspberry or the one for peach. But for raspberry, the product ID, the P2.product ID value is null. And if I try and count that, of course, the count function doesn't see that null value, and so this comes out as 0. And if you go back and revisit the queries we've done, counting the number of more expensive products, you will notice this is way cleaner than any of those, because those required us to jump through a few hoops. They required us not only to find some clever way of joining stuff up, as opposed to the on clause of an inner or outer join, but they also required us to use some extra logic, either a funny case when statement or a union or something, to pull in that row for raspberries because we didn't know what an outer join was. So now that we do, we suddenly have a lot more power and we have a lot more, we can be more concise with our queries. So that's the second short little topic we have to talk about, just reviewing all the different joins. As far as the new bits of SQL we have yet to see, we have to talk a bit about how Postgres handles dates and times, which isn't really a new SQL topic. It's mostly sort of annoying function stuff. Then we have to talk about the last big SQL topic, which is really advanced SQL, which is something called window functions, which will, a lot of you will have a lot of fun with window functions on assignment 4.